We know that the linear system can have no solutions, one solution, or infinitely many solutions. We also know when we are done with the row reduction procedure. Now you want to know, of course, how we can see the number of solutions after the row reduction. That is the subject of this video. How can we find the number of solutions of a linear system? First step, always reduce to echelon form. Step 1. Step 2. Is there a row of the form 0, 0, 0, 0, so with all zeros, and after the bar a number which is not equal to 0? In that case, we have an equation of the form 0x1 plus 0x2 up till 0xn equals something non-zero. So 0 equals something non-zero. We can, of course, never find a solution of that, and in that case the system is called inconsistent and it does not have solutions. Example over here, we have a row 0, 0, 2. That means 0 times x1 plus 0 times x2 equals 2. Sorry, typo. Doesn't matter, it means 0 equals something non-zero, which means that the system has no solutions. So you can spot that right away. Suppose you have spotted that this is not the case, so we are not in this case. So suppose the system is consistent. What can we have then? Well, it can be the case that the system has a free variable, that we have more variables than equations, like over here. 2 variables and only one equation is left. In that case we have a free variable, or maybe we have more free variables. Well, if you are able to choose a variable for free, that means that I can have an infinite number of solutions, because I can choose any number for the free variable. So in this case you can, for example, choose x2 to be free, and I express x1 in terms of x2. And we have an infinite number of solutions. Well, the last case, if my system is consistent, and if I don't have a free variable, then I'm of course in the last case. In that case, the system has one solution, like the example over here. There's no row of the form 0, 0, something, and there's no free variable, so we have one solution, x2 equals 2. You can read it off right away and then compute x1 to be minus 1. So that is how you can find the number of solutions of a linear system. Let us do an example which is a bit bigger. So here we have 3 equations with 3 unknowns. Actually, this is an old exam question. Every one of the equations represents a plane, so we have 3 planes in R3, and the question is, how do these planes lie with respect to each other? How do they intersect each other? In order to find it out, we have to solve this linear system. So let's try. First of all, you want a 1 over here and zeros here and there, preferably. Well, the 1 is already there. How convenient. How do we get zeros here and there? By adding the first equation minus 2 times to the second one and adding it up once to the third equation and copying the first one. So we copy the first equation, then minus 2 times 1 equals minus 2 plus 2 equals 0, minus 2 times minus 2 times minus 2 equals 4, added to minus 1 equals 3, minus 2 times 3 equals minus 6, added to 3 you get minus 3, minus 2 times 4 equals minus 8, added to 2 equals minus 6. That becomes the second row, and the third row, add the first row to the third one, 0, minus 2, 6, sorry, minus 6, 6, and 12. There we are. And then we see that we can simplify a bit by multiplying this one with 1/3, this one with minus 1/6, and then we find, copy the first line, 0, 1, minus 1, minus 2, 0, 1, minus 1, minus 2. Now I want a 1 over here, which we have already made in the previous step, and a 0 over here. Well, that's easy. We can get rid of the entire last row by subtracting it once. And we get a row of zeros, which is perfectly fine. And then we want to go to reduced echelon form. We are already in echelon form because the leading entries are to the right of each other. Now, how do we get reduced echelon form? By making a 0 here as well, by adding it 2 times over here. So we get 2 times 0 equals 0 plus 1 equals 1. 2 times 1 equals 2 minus 2 equals 0. 2 times minus 1 equals minus 2. Added 2, 3 equals 1. 2 times minus 2 equals minus 4. Added 4 yields 0. And there we have our reduced echelon form. And now we can find the solution of the system. We have 2 equations and 3 unknowns. That means that we can choose a parameter free. In this case, we have pivots in the first and second column, and we decide to choose the third parameter for free. So x3 equals 3. Then we can express x1 and x2 in terms of x3. x1 plus x3 equals 0, so x1 equals minus x3. And x2 minus x3 equals minus 2, so x2 equals minus 2 plus x3. So there we have x3, x1 and x2. Mind, by the way, there is no equality sign over here. It wouldn't make sense, because x3 cannot be equal to some word. So that's why it's always written as just x3 is 3. No equality sign there, please. And then we see something nice if you put x1, x2, x3 and a vector. That form of the solution is called the parametric vector form of the solution. Or we put x1, x2 and x3 in a vector. So x3 is just there. x1 equals minus x3 on the first spot. And x2 equals minus 2 plus x3 on the second spot. And we see we can rewrite it as 0 minus 2, 0 plus x3 times minus 1, 1, 1. And now we recognize the form of the solution. This is the parametric form of a line. So that means that the points satisfying the linear system all lie on a line. But those points satisfying the system were points of intersection of those 3 original planes. And that means that our 3 planes intersect in a line. So that's what we can conclude, and we can see it explicitly due to this parametric vector form of the solution. So now you know how to find the number of solutions of a linear system, know how to find parametric vector form of a system, so you definitely now want to try this yourself.